Welcome to my new calculus channel. My name is John Gabriel. In a previous video, I explained to you how we derive the unit and what the abstract unit actually means. And naturally, what follows on that is the meaning of an equivalent fraction. Now remember, all numbers are fractions. The ones that cannot be measured, in other words, that cannot be stated as a form of a fraction, the magnitudes that can't be described by a fraction are those that are incommensurable magnitudes. That means they have no common measure with others. So an equivalent fraction will be explained in this video. Excuse me, all numbers are without any exception fractions. A number describes the measure of a magnitude by magnitudes other than the given magnitude. And of course, nobody after Euclid and before me actually understood this. So let's see how this works. The abstract unit does not care which magnitude is used. For example, in this particular case, you've got the consequent here, which appears after the colon that you see here. This is called the consequence or the denominator, the consequent or the denominator, and this is the antecedent or the numerator. Now you'll see that the unit is made up of 4 equal parts, and the numerator tells us how many of those parts we want. So in this case here, we're really talking about 3/4. And similarly, we could also express an equivalent fraction by letting the unit consist of 8 equal parts and numerate 6 of those, right? So that means that in terms of dimensionless units, 3/4 is equal to 6/8. All right, so both represent the dimensionless number or fraction that we know as 3/4 or 6/8 or 9/12 or any other equivalent fraction. Now notice that a different unit is used in 1 and in 2. The unit used in 1 is this unit here, and the unit used in 2 is this length here, this unit. But 3/4 doesn't actually care about that because it's dimensionless. Okay, now here comes the snag. In the following examples of physical measure, now this is very important. We're using this as the unit of physical measure, okay? So this is a particular measure that we apply when we try to see how long a particular distance is. So in this example of physical measure, 3/4 is equal to 6/8 because the unit shown in the square brackets is the same. In other words, this unit is the same as this unit, even though this unit here has been divided into 4 equal parts, and this same unit has been divided into 8 equal parts, okay? So in this case here, 3/4 is equal to exactly 6/8 in physical measure. Now in the next example of physical measure again, 3/4 is not equal to 6/8. Why? Because the same unit is not used. This length is not equal to this length. Does that make sense? Okay, in other words, if we're looking at 3/4 of this unit, it's much longer than 3/4 of this unit. Okay? I mean, it doesn't even matter if you divided this unit into 4 equal parts and took 3 of them. Like 1, 2, 3. Yes? Okay, so you can see that there is a difference when you're talking about physical measure and abstract measure. So again, looking at the example on the previous page, this unit here is longer than this one, right? This is longer than this one. So if you understood all this, you already know what mainstream mathematics professors never understood. And in many instances, you're a lot smarter than them. So go over this again, pause, hit the pause button, and try to understand everything I've told you. it is vitally important to realize these facts, because without the knowledge of these facts, you can never fully understand what is a number. And if you don't know what is a number, you have no business doing mathematics. I'm John Gabriel, and this is the New Calculus Channel. Till next time, goodbye.